Many of us believe that coding interview is number one, challenging, number two, time consuming. But this may not be the case if you are in right place. If you come to this site, which is quickcode.com, it starts with kuickcod.com. You will find, if you go to the algorithm and data structure sections, then you will see a lot of algorithm and data structures, arranged by study plan, like week 1, week 2, week 3, and also there are more algorithm and data structure that you will find. So in order to address those two issues of time consuming and challenging, this site is built so that the new people who are studying algorithm and data structure will find it very, very easy to understand and grasp the core idea of data structure and algorithm. So for example, the week 1 plan, right? So if we come to week 1, so the first problem is contains duplicate. So basically the problem says given an integer array nums, return the true if any value appears at least twice in the array, and return false if every element is distinct. So this is a very, very simple problem, right? So what is in there? So say for example, this is an array 1 2 3 1. So see, 1 appears twice, here in the beginning and at the end. That means it has duplicate, so we return true, right? In this example, 1 2 3 4, there's no repetition, so return false. So how to solve that is very, very simple. All you have to do is to declare a hash set. The property of hash set that it contains only unique elements, right? So we'll iterate through the nums array and then check if the array element already in the hash set. If it is already in the hash set, that means duplicate exists, so we will return true. Else we just add that value to the set, and then finally we will return false. So this is very, very simple problem. So if you want to execute this problem, here you can write your own code and click execute, and then see what is the result. So now this is empty, so it is giving error. So let me copy this code and paste in here and then execute. So it's succeeded. So answer is true, right? So when you execute this code, it will run on this input. You can change the input here. So for example, if I make it 4, the answer should be false, right? So let's execute. So answer is false. So this code is right. But if you submit internally, it will execute on like 20 to 25 test cases, and it will validate the result of each of the test cases that is applied on this code. And if all the test cases pass, then it will return true. So this is a very basic editor where you have to provide opening and closing brace. It works like a text pad, so that if you practice writing code here, it will be same as writing code in the real interview. So you can use this one. It's very helpful. Okay, so here also, right, all these problems are arranged in order of complexity and dependency. So the knowledge that is required to solve contains duplicate problem will be used in twosome, all right, so that it becomes easier for you to understand. So what is a twosome problem? It's very, very important and very, very simple problem. Given an array of integers and a target integer, find two elements from the array whose sum is equal to target. Return an array of two distinct indices of the two elements. The input will always have at least one solution. So basically, given this array, and we have to see if two random elements sum up to target or not. So in this case, if we say 5 and 3, 5 plus 3 is target, right? 5 plus 3 is 8. So it is so answer will be the index of these two elements. So 0 1 2, the index will be 0 1 2 3, so 3 and 4. So we'll return an array having value 3 and 4. That will be the answer, right? Or okay, so that also we can have answer from here, right? This 5 and 3, so answer can be from here also 0 and 3. Okay, so let's see the code. The code is very, very easy. So we'll define a hash map, right? The value will be the value of the array, and the key, sorry, the key will be value of the array, and value of the map will be the index of the array, right? So we'll iterate the array, and then we'll create a new target by subtracting the current value, current element from the target, and you get a new target. If this new target exists in the map, then obviously we found a solution. So we'll just return the index of the new target and the index of the current element, and if it and then we'll add the current element and its index to the map, right? So once this loops will execute somewhere this statement will be executed, and we'll get the result. This will never get executed because the input will always have one solution, right? So you can write your code here similarly, and then execute. Let me copy and then execute the code here and run. Okay, it's succeeded. Okay, let's go to next one. Next one is best time to buy and sell stock. So you are given an array prices where prices I is the price of a given stock on the ith day. You want to maximize your profit by choosing a single day to buy one stock and choosing a different day in the future to sell that stock. Return the maximum profit you can achieve from the transaction. If you cannot achieve any profit, return 0. So basically an array is given, and these are the prices. So 0th index are the days. So 0th day price is 7, day 1 price is 1, day 2 price is 5, like that. So all you have to do, you have to buy once and then sell once and see and make maximum profit. So all you have to do is to buy when the price is the lowest, so in this case 1, right? And then sell when the price is the highest, so in this case 6. So 6 minus 1 is 5, so 5 is the answer, right? So what are we doing here? We are keeping track of the minimum price and the maximum price, right? So that's the key idea. Keep track of minimum price and maximum price, and then see the max profit, and that will be the answer. So here we declared a mean variable, right? Initialize to max value, because if you want to find minimum value, we always initialize with max value. And the profit also, there's one more variable, profit 0. So this profit will hold the maximum profit that we find so far as we iterate the array. So we are iterating the array. So mean initially is very high value, right? So this, whatever the price is there, the first price is there, this condition will fail. So it will come here, and mean will be populated with the price. That is the first day's price. And then next time, if the next day price is greater than the previous day, then there is a chance of profit, right? So we'll see what is the profit. So current price minus previous day price, right? That's the profit, and initially profit is 0. So some profit will be there to be kept in here. So this profit will keep track of the max profit that can be found so far as we iterate the array. And then finally, the profit will hold the maximum profit and will return that, right? So we can execute this code. So now we already copied it here. So we can execute this code here and then see the result is 5, right? So result is 5. So yeah, result is 5, right? So you can change the value here. So let's say instead of, so the result came from 6 minus 1 is 5. So let me make it 7. So the result will be, in this case, 6, right? So let's execute. Result is 6, right? So okay, next go to the next one, which is merge two sorted lists. So one list is given here, the sorted list at 1, 2, 3 in ascending order. Another list 1, 3, 4. Like we have to merge these two, so that the merged list also in the sorted order. Like 1, this 1, 1, 1, then these 2, then these 3, these three, then this 4 and this 4, 4 and 4, like that. So this is the linked list, and a one-way linked list. So what do we have to do? Two lists are given here. So now we create another head, right? New head, and then we create an answer node, and then assign the head in here. So this answer.next will be our answer, and we'll use the head to generate the merged list and traverse the merged list. So when we traverse, it will go from beginning to end, so we cannot return it as an answer, but we have to use ans.next as an answer. So in the while loop, right, we are iterating the list as long as both of them are not null, right? So get the value from the first list and get the value from the second list, v1 and v2, and then check if the v1 less than v2. So if the v1 is less, whichever is less will be assigned to the our merged list, right? So head.next equals to list 1, because v1 is small, so we take the list 1 and put it in the head.next, because we are creating the merged list. And then we will move the list 1 one step, because we took the node from the list 1, so we are not taking the node again, so we are moving it one step. And similarly, if v1 is bigger, then we'll do the opposite in here. And finally, we'll move the head one step ahead, right? So we are building the merged list. So once this whole loop is done, then one of the list will be empty, so, and the other will be not empty. So whatever is not empty, we'll just add it to the head, that is add it to the last element of the merged list. So here, if a list 1 is not null, then we'll take list 1 and then add it to the end of the merged list, otherwise we'll take list 2, and finally we'll return ans.next. So that's it here. So yeah, I'm sorry, I just forgot to talk about the time complexity and space complexity. So time complexity and space complexity is here. The time complexity is order of n, because I'll visit list nodes only once, and here n is the total number of nodes in both the list, right? And the space complexity is 1, because I'll not be declaring any data type, which will grow proportionally with the input. So if you come to this side, right, there's a key ideas that explain like what is going on here, and then so every problem, all the previous problem, if you go here, so you'll find key ideas, key insights, clarifications, and time complexity and space complexity, and then let's go to a binary search. So binary search, you already know, so I'm not going in detail, right? So only thing I'm just telling, if the element exists in the binary search, then we return the index, right? If the element doesn't exist, the question might ask what is the insert location. Then in that case, we'll return left, because in the binary search, left pointer moves to the right and right pointer moves to the left. So left pointer will be moving to the end of the array, index +1. So the left will be the insert location. And sometimes the question might ask that if the element doesn't exist, then return -1. So we'll be returning -1 in this case. So binary search is here, this is iterative approach, and this is recursive approach. So let's see the valid diagrams. So this valid anagram, sorry. So what is anagram? Anagram is given two strings, right? If we take each of the letter, can we map each a if each of the letter also exists in here or not, right? So one-to-one mapping. If it exists, then we cannot use it again. So basically, the length of these two string has to be same, and each letter should map to another. Each letter of S should match with another letter of T, exactly same, right? And only once. So if that is the case, then that is the anagram. basically, if we take all, if we say this is a page, on this page this letter is, this is on a paper, there these are the two letters, right? And if we cut this individual letter, can we make this letter? If yes, then it's an anagram. So how to do that? So basically, if the string length are not same, then we return false, that is not an anagram. And otherwise, these strings consist of lowercase English letters, so we'll create an array of size 26 because 26 alphabets we have, right? And then we will get the character from S, right? And then get the index, which is minus A. So, and then we'll increment the occurrence of S, and we'll decrement the occurrence of character of T, right? So if both the string has same character, same occurrence of characters, right, then the ultimate result will be 0. One will increase the occurrence, other will decrease the occurrence to the same extent, right? And then finally we will look at the occurrence array, and then if there is any value which is not 0, then we return false, otherwise we return true. So this is anagram. So there are a lot of things. See how many we covered, like 1 2 3 4 5 6. We covered 6 in like around 16 or 17 minutes. So so it will take like 1 hour or something, or 2 hours. So basically it's very quick, right, to prepare for like 10 12 like easy problems, and then prepare for interview, because these questions are very highly curated, and highly likely to to be faced in the interview. So we have a week 1 plan, then we have week 2 plan, right? I'll be adding more in here, and then we have week 3 plan, I'll be adding more in here. Week 4 plan, so I'll be adding more in here because I'm still in work in progress. So we have more problems that you more problems than you need, right? Like top rated, and then binary tree. We have lots of binary tree problems, like find duplicate subtrees, find mode in the binary search tree, and house robot tree, get the smallest element in BST, and there's more and more. Some tricky problems, right? We have the longest substring without repeating character, minimum size subarray. So you can have a look and see what are the problems in here. So we have a lot of array problems, right? Car fleet collisions, couple holding hands, majority element, largest number, there are a lot more than I can say here. So we have 2D array, and we have a lot of design problems, right? Design hit counter, design phone directory, and a lot of dynamic programmings, right? Maximum rectangle, palindrome two, largest palindromic subsequence, and a lot more you can see. And the graph problems, right? Find the celebrity, and graph valid tree, and longest path in a directed graph, number of provinces, and we have a lot of problem in the linked list. So guys, if you are new, this is very good site, because you do not know what to study and what not, right? And then how quickly you can study. So visit this place, quickcode.com. It starts with a KUICKCOD.com, and explore. Enjoy. Thank you. Bye.